Say hi, girl.
Good morning, doctor.
Okay. Good morning. Right. All right. So, the first thing that before we start our class today, I just want to make an announcement. Just to reconfirm the venue of our test that will be on this coming Sunday. So, right. So the test will be on the 22nd May, 2022. This coming Sunday, time is our class 11 to 1 p.m. And then the venue will be floor 4, all right, room O2. So it will be in the TO8 building, right? So for those who haven't come to our faculty, please make sure during these weekends, okay, so make a tour and then try to find where TO8 is, all right? So you really need to know where your faculty is, okay, in order to be more, to feel more belong to UTM and also HITS, right? So that will be our test, okay? The test will take about 1 hour and 30 minutes, but I would like you to be at 11, all right, before 11, in order for me to arrange all of you who will come on this Sunday, this coming Sunday, okay? So let's continue with our lecture, which is T-test, okay? Just to remind you what we have learned in our previous meeting, that t-test will be used, okay, for inferential statistics when we have n less than 30, right? So t-test, okay, t-test, okay, we use when we have small sample size, which is n less than 30. So we have learned for the when the case when we have only one sample. Okay, so one sample. So what we need to do, right? So I have shown you how to do it manually, right? When where you need to, when you have raw data, where you need to enter the data using your calculator and also SPSS in order to get the information from the sample in order to estimate the population. So today we are going to do the next topic, which is regarding the two population. Okay, so instead of having just one sample, now we have two populations and we are going to take two samples, all right? Sample from each population, right? So we are going to do the same thing. We're going to estimate and then we are going to do the hypothesis testing. I'll show you how to do it manually and also using SPSS, right? So for the two samples, we have two conditions, right? So the first one, we call it as independent samples. So when I say independent samples, it means that I have two samples, right? But these two samples, let's say sample 1 and sample 2, actually come from population 1 and population 2. So these two samples are not related at all. They are totally different. So for example, I have stuff from Celcom and also from DG. So they are two different entities. So I take the sample from Celcom and then I also take some sample from DG. All right. So that's what we call it as independent sample, where the two samples are not related. They are they are exclusive. Sorry. Okay. Suppose we want to estimate the difference between the mean salaries of all male and all female executive. Okay, so to do so, we draw two samples, one from the population of male, okay, male executive. So we have male, and then we have female executive. So male and female are two totally different group, right? So we take some, let's say from the male, let's say I take n is equal, so n1, so the first one I take 15, And then for the female executive, okay, for N2, I take, let's say, only 8 people, for example. So this one, that's what we call it as independent samples, right? Another one, another sample that maybe is easy for you to understand is when we have two different universities, okay? So I would like to compare the statistics marks from students from UTM and also students from USM. So what happened, I take some sample, okay? They have same classes, okay, statistics, let's say business statistics. So I would like to compare their marks, all right? So I take some student from UTM who's taking that subject, and also USM students who are taking that subject, right? So let's say I have UTM, for example, right? The purpose is actually when we are doing, okay, the two samples is to compare, okay? This is our purpose, is to compare and okay, to look at, oh, all right, to look at the differences, okay? That's actually our purpose. So let's say I have student from UTM, so the scores is 90, 87, 66, right? And then 70, and then I have 91, for example. So I have 5 students from UTM, right? So N1 is equal to 5. So the number of sample, or I can also write it as N for UTM is equal to 5. Right. And then I have USM. So I also take some students from USM. So I have 91, 78, 63, 58, 41, 30, right? For example. So I have 2, 4, 6. So N for USM is equal to 6, right? So when I look, before we can do comparison between these two samples, or before we can do data analysis on these two samples, we need to look at something that we call it as variance. Okay. So it means, okay, we need to look at the variance between these two groups. What does it mean by variance? Variance mean when I say one of the assumptions for the T2 sample t-test, they must have equal variance. Okay, so equal variance means that they have almost similar marks. Okay, where we cannot identify the differences by looking, by just looking at the scores from the two universities, right? So in our case, if we look at the UTM student, okay, the UTM scores and also the USM scores, just by looking at these scores, we can see that it is quite unfair. Okay, it is quite unfair to compare these two groups. Okay, why? Because if you see that UTM, the 5 students are all good students. They have a very high score. But when I look at the USM scores, it is a little bit unfair because there are some students who have a very low score. Okay. So it is very, very unfair to compare these two groups because they have not equal variance. The variance is not equal because one is good, the other one is not good. So in the real life, okay, when we do a research, when we want to compare this one, so it means that we don't need the t-test, we don't need the, using SPSS and the analysis, because I can say that USM is, the score is lower than UTM scores, right? Because of these people right here. They really affect, okay? in terms of the mean, right? So what I want you to do now, people, so can you please find the mean, okay, for UTM, scores for UTM, and the mean for USM, right? Can you find the mean? So tell me. What is the mean? Okay, Roha, for Roha, can you just say it? Because you know what? I cannot, sometimes my eyes
The
is
mean
not,
for
sorry, which one? For UTM?
yes, UTM is 0.8.
0.8. Thank you, Roha. Okay, how about USM? Anyone? Can somebody read it for me?
60.17.
17. Okay, thank you. Thank you. All right. Okay, so look at the average or the mean of these two groups. So what can I say? I don't have to do any analysis. I already know that USM scores are actually lower than the UTM scores, right? So it's very, very unfair for us to compare the scores between these two group of students, okay? So all right, when we want to do data analysis, when do we need to do the data analysis? When we don't even know which one is going to be better. Are they going to be the same? Okay, different, greater than, or less than? Okay, we don't know. So that's the reason we do data analysis. So in real life, when this thing happen, when we don't have equal variance between the groups, so we need to replace all these three people, right, with somebody else in order to be equal to the others, right? It doesn't matter from UTM or the other USM, right? So the next one, what I want you to do, I want you to find the mean for all of them, right? So just add 90 plus 87 plus blah blah until 30, and you divide by 11. Can you get the answer for me? So I just want to find what is actually the mean for this one, for these two groups.
Doctor,
Yes,
the number is 69.55.
0.55. Okay. So if you see, just looking at the mean, okay, it's quite far from those people who got 90. Okay, the difference is almost 20. All right. So, and then this is for people who have scores like 63 or 66. They are closer to the grand mean, okay, for the mean for the whole samples. So for those people who have 90 or 91, it's quite far from them. Why? Because this one is affected by these three people. All right, so we need to change that one. We need to improve the mean in order to be fair to everyone in our sample, right? So that's what we call it as two two samples, all right? Independent two samples. But before we can do any comparison or before we can do the data analysis, we want to make sure that they have equal variance. Okay, paham ke? Is everybody okay? Yeah, any questions before we proceed to the next one? Okay, right. So again, then in our case, so it's good if we have like people. We want to compare these two groups like if they have, like 67, 91, 90, okay? So, and then this one also the same, 88, 78, 93, 69, like 78. Okay, they look more similar, right? So then it's okay for us to compare these two groups in order to find the differences, to look at the differences. Okay, that one is independent samples. Now let's talk about dependent or matched paired samples. Okay, I usually call it as dependent and paired sample. Okay, many books, okay, many statistics book call it as matched sample, paired samples, or dependent samples. So they mean actually they mean the same, right? Suppose we want to estimate the difference between the mean weights of all participants before and after. Okay, it's quite popular before and after situation. Weight loss program to accomplish this. Okay, suppose we take a sample of 28 participants and measure their weights before and after the completion of this program. Note that these two samples include the same 28 participants, for example. So what is the difference between independent and dependent samples? Okay, for the dependent samples, all right, so again, we have two groups, okay, we have two groups. But this time, if independent, the two groups are not related at all. Okay, group one, okay, we can say group one, oops, group one, and group two, okay, for the independent, they are two different entities, two different groups, okay. But for the dependent, actually they must be related. What does it mean by it must be related? So, for example, okay, I have CA, okay, CA, and then I have CB, Mr. C, okay, okay, okay. So, and then for my second sample, I have the same people, right? I have Chick A, Chick B, and also Mr. C, right? So it means that I'm going to have the same persons, the same people for my group one and group two. But I repeat them, I reuse them, I recycle them for the second time. So usually for the dependent samples, we have situation before and after, okay, pre and post, for example, okay. And then these are very, very popular situation that we use for the dependent samples, right? We use same people, but for different situation, okay? Different situation, mm, different time, and then for different purpose, for example, right? And then different location can also happen. So for example, when I say different situation, so before and after, so one of quite very um, popular situation, all right, is for diet. Eh? So we measure people's weight before the diet program and after the diet program, for example, and also that's what we call it as intervention, right? So here in the middle, we have intervention. So what does it mean by intervention? Okay, so for example, we give them workshop, we give them, like a certain program for them to improve the situation. Okay, so that's what we call it as before and after, or pre and post situation. So for example, we have these three staff, they are not very good at IT. Okay, so what happened? The company sent them to a workshop or a course, a IT course for 3 months. Okay, so IT course IT course for 3 months, and after 3 months, so we are hoping that they will improve their IT skills. Okay, so then we can see whether the IT course is actually effective in terms of improving the staff in their IT skills. Okay, another example, pre and post. For example, this is actually the dependent samples, very popular among the doctors and also psychologists and psychiatrists. Okay, so for example, a doctor, they want to introduce a new medication for heart problem. Okay, so what happened? They measure the heart rate and before they take the new medication. So and then after, let's say, after 2 weeks, the patients come back to the doctor and then inform the doctor whether their heart problem has been improved or not. Okay, so we want to check actually whether that new medication is effective for heart problem. Okay, so that's what we call it as dependent sample. Right. So what I want you to do, guys, okay, I want you to go to page for this t-test, right? So we are going to do the dependent sample first, and then we'll do the independent sample. So the independent sample will be next week, okay? So let's go to page 101, right? Okay, assumptions, right? So assumption for the dependent paired or matched sample. Okay, the first one, the sample should be normally distributed. Okay, this one is the assumption. Should be normally distributed. The second one, okay, uh, should be randomly selected. So you need to select your subject, okay, your respondents random. Okay, you cannot be biased. And then in terms of the variances are equal, right? And then the two samples are related or dependent, right? Right. So that's the assumptions uh, for the dependent t-test, right? So for examples, I already mentioned just now. So maybe you can copy this one down for the examples of the dependent samples, okay? Like, just now we have the diet program, and then also in terms of IT course for 3 months, and then it's supposed to be okay, the same people, right? Usually we use the same people, but for different situation, different time. For example, we use them, we give them a test, IQ test, in let's say May 2022, and then we give them again the IQ test in June 2022. And then we would like to compare whether they have improved their IQ, within 1 month, for example. So that one is different time, and then also different purpose. So we want to look at, so for example, they use type A, and then we also give them type B. So we want to compare which one is brand A and also brand B. So which one is better for them, for example, right? And then different location, you test them, in Johor Bahru, and later you bring them to Kuala Lumpur. So maybe because of the location may affect their personality and so on, for example, right? So those are some of the examples for the dependent sample. Okay, so in terms of the distribution, right? So the first thing I will let you know actually how you want to calculate, all right, the mean. So the mean, how to calculate from the raw data given, all right? So if you look at on page 102, right? So we have three different columns, okay? So the first column is actually we call it as treatment one. Okay, why in statistics we use the word treatment? Because as I said, this dependent samples is very popular among the doctors, among the medical people, psychiatrists, and also psychologists. So usually they always give treatment to the patients. So that's why the word treatment is very popular in statistic for the dependent samples, right? So we say treatment one, and then treatment two. So maybe treatment one before, treatment two after, and then we need to add one more column in order to find the differences between the two treatments. Okay, so when we do exercise 11, you will understand better what I'm trying to say. Okay, so for the mean, if you see, all right, when you we use, okay, the mean here. Before this, we write mean for x bar. Remember, but this time we use mean for d bar. So d is actually the word difference. Okay, so you need to understand that. Or sometimes we also use x bar 1 minus x bar 2, right? So this is the difference. So the D is actually mean sample treatment 1 minus treatment 2, right? So that's what it means by the letter D, all right? And then standard deviation, same thing, okay? So we get the standard deviation from the population, okay? And then we divide by n, all right? The confidence interval also the same. But the additional, as I said, for the t-test, we have the value of df, which is n minus 1. Okay, so let's try, okay? I will show you how to calculate manually first, and then we will use the steps, okay? Just like what we did in one sample using SPSS after this, right? So let's try this one, example number 11. Okay, so a medical researcher wanted to investigate whether a new drug, okay, is effective. Okay, now you want to investigate the new drug is effective. So that's our purpose in reducing blood pressure. So the clue word here is reducing. Okay. So we are given raw data. So these are all the blood pressure, the BP measurements that the doctor get before and after, okay? Before they take the drug and after taking the drug. Okay, so this is the new, the clue that you need to understand. So we want to, our purpose is to see whether the drug dekat dalam kes ni ialah ubat medication. So the American call it as drug. So when you go to US, you can see drugstore, drugstore, drugstore. Okay, so drugstore is actually pharmacy in US. So not selling drugs like in Malaysia. Okay, kalau we can see drugstore dekat Malaysia ni, it's very very dangerous. It means something else. All right. Okay, and then we need to do hypothesis testing. So why we want to use hypothesis, when and how? We know that this question is for hypothesis testing because one thing, right? So we are given sufficient evidence to support the claim, right? So claim is actually hypothesis, okay? And then when we are given the alpha level, so alpha is always used especially for the hypothesis test. So you know that this question, you need to perform the 4 steps of the hypothesis testing. Right. So let's do one by one first. Right. So in order to answer this question, okay, so as I said, we need to do it manually first. Okay. So what you need to do, so let's say this one, I say before, and then this one after they take the drugs or the medication, the ubat, all right? So the next one, we need to have one more column for the difference. So which is the D, right? So then you need to add one more column here, or it doesn't matter whether you want to do, horizontally or vertically, the table vertically or horizontally, it doesn't matter, right? So, but the most important, you must have the treatment number one, information treatment number one, treatment number two, and then you need to find the difference. What does it mean by difference? By, okay, you need to subtract before, subtract after, okay? So our difference here, I can say, okay, treatment number one minus treatment number two, or before minus after, right? So actually you can also, some books, they use treatment 2 minus treatment 1. But for my students, I want all of you to do this way. You must subtract the first treatment, subtract the second treatment in order to get the value of your difference. So for example, 17 minus 2, so you have the difference is 2. 80 minus 72, so you have 8. And then this one 10, so 6. Okay, if the difference, for example, this one, 68 minus 72 is minus 4, you need to put it minus 4, right? So you cannot put it as positive 4. So minus negative is always negative. So can you please do it now on page 103? Find the difference first. Okay, so are you okay? All right. Let me get someone to give me the answer. Fernandika, are you here?
Yes, doctor.
Okay, can you read me all the answers? So just say 2, 8, 10, 6. Can you give me all the answers?
8,
Right?
10,
Hmm?
4, 16, 18, minus 8, 0, 32, 0, plus is 10.
Okay. Is everybody okay with the answers?
Doctor,
Yes?
I think for 76 minus 58 is 18.
Which one, Atika?
The fifth one from the left.
1, 2, 3, 4, 5, 6. This one?
The fifth one, 76 minus 58.
Yeah, okay.
It's supposed to be 18, 1 8.
1, 8. Right, thank you, Tika.
Then one more, I think for 78 minus 52.
Yeah.
Yeah, yeah.
Huh?
It's supposed to be 26.
Okay, thank you. Anything else?
and the rest is correct.
Okay, all right. Thank you very much. Okay, so what I want you to do, okay, next, okay. By the way, remember I told you the main objective of doing the two sample t-test is actually to find differences. Remember? Okay, to look at the differences, to find whether they are different or not. Remember I mentioned that one just now. Okay, so what is the problem here? If we can see, all right. So for example, this part right here, okay, the difference is 0. Okay, these two. Therefore, actually we already know these two data, right? These two information, they got no difference. No, we don't have to do any data analysis. We already know that these two is actually got no difference. So it beat our purpose of doing the t-test. So what we need to do, any zero differences, okay, we need to remove from our data set because they are not suitable to be analyzed because they got no difference. We already know it. Okay, so you need to cancel that one out, okay, for these two data. So now we have how many data left? Anyone? So how many data that we have?
1, 3.
13, all right? So originally we have 15 data, but because we already removed these two data, so left us with 13 data only. Is everybody okay? Understand? Okay, now when you want to enter the data in your calculator, right? So you need to enter only this difference part, all right? The difference column or difference row. So you need to enter 2 and plus 8 and plus 10 and plus 6 and plus 18 and plus. And don't forget, when it comes to the negative number, you need to put negative 8 and plus, negative 4 and plus. You cannot miss the negative 1. So can you please do it now? And then tell me the mean and also the standard deviation that you got from your calculator. Yes.
10, 10,
10.
0.15.
Okay, can you say it again? 10.15. Is that
15.
correct? Like this?
Yeah,
Okay, thank you. All right. How about the standard deviation?
11.21.
Right? Is everybody okay with Esther's answers? Okay? Okay, great. Right. So that's how actually we get, when we already get this one, it's easy for us to write the distribution. I think everybody already know how to write the distribution. So let's do it, okay? So is there, in order to answer the second part, all right? So is there sufficient evidence to support the claim that the new drug is effective in lowering blood pressure using 0.05 significance level? Okay, so since we are using SPSS, so it means that we only have two uh sorry, we have only four steps, all right? And then we have step 3 and also step number 4. Right. So the first one, we need to find the distribution first, okay? So we have x n mu sigma square, right? So we have x n 10.15, and then just like what we got before, 11.21 square, right? And then for the distribution, for the difference, okay, that's the difference, okay, that I use a little bit in order to differentiate. This one is actually for the dependent t-test. We use all the differences, okay, 10.15, and then in order to get the S for D, right? So we get S square root of n. So S is actually we use when we have small number of n, right? So or you can even use the sigma x bar, right? It will be the same thing. So in this case, we have as 11.21 divide by 13. So can somebody give me the answer for this one? Anyone?
Point
The
one.
third, the
Yes.
answer is 3.11.
3.11. Is that right, Roha?
Yep.
Okay, square, right? So once you get this new distribution, don't forget to box it. Okay, why I always ask you to box it? To remind you, this is all the values that you need to use for the future, for the next steps, all right? So because sometimes when we are human, we tend to look at all the numbers sometimes, oh, we take the 11.21, so it's going to be wrong, right? So the next one, okay, for the for the two samples, okay, the hypothesis will be slightly different than what we did in one sample, right? So usually we put it like this. Mean 1 is equal to mean 2, right? So it means that treatment 1 is it equal to treatment number 2. Okay, so in our case, so we want to claim if the medication is effective in lowering the blood pressure. So for sure, okay, what I can say here, we have this one, okay, before and after, right? So the blood pressure here, okay, BP before, the BP after. So what do you think? Which one will be greater than the other one? Okay, if it is effective in reducing the blood pressure. So the BP before or after, which one is higher?
BP before.
BP before will be higher than BP after. Nak sebut BP tu macam susahnya. Okay. So it means kalau if the BP after is lower than BP before, it means that the new drug will be effective in reducing the blood pressure. So in order to decide what symbol that we need in our HA, so we need to think logically, right? So in this case, so we have BP before should be higher than BP after, right? Or you can either write it this way, okay? So let me put it this way, okay? I can say this one first, okay? So I can say HOU before equal to mean after. So you can say, oh, this one before and after. Or I can even write it this way. Okay, the H naught mean before minus mean after is equal to 0. When I bring this one to the left, so the equation will be like this, okay? So how do I read it? So I can read it, okay, the first one, the way I write it, okay, mean before equal to mean after. So it means equal, so no difference, okay? Or I can say the difference when I say, okay, this part right here, okay, this part right here. So this one, when we subtract something, so in mathematics, we call it as difference, okay? So I can say the difference before and after is actually equal to 0. So there is no changes. So that's what it means, okay? And I also can write, okay, HA mean before should be higher than mean after, right? So, and then, or I can write it this way, mean before minus mean after greater than 0. So in your test, in your final exam, you can write either way. Okay, I will accept either you write it mean before equal to mean after, or mean before minus mean after is equal to 0. Also, I will accept both of them, right? So you don't have to worry much. Or you can write it also mean 1 is equal to mean 2, right? So the most important I would like to see you really understand what you are doing, right? Okay. So what we are doing is actually to prepare us before we can use our SPSS, right? So let's say step number 3 just now, okay? So step number 3, okay? But before that, for step number 1, we also need to do the assumptions. So we need to put dependent t-test, okay? For step number 1, because our n is greater than 30, and then we have 2 samples, okay, 2 dependent samples, right? So that you need to write in your step number 1, right? For step number 3, okay, we need to find, okay, whether we need to decide 1 or 2 tail, right? And then is it 1 or 2 tail? And then we also need to decide whether what is our alpha, what is our sigval that we get from the SPSS. And later on, we need to make decision, reject or accept H naught. Okay, so when do we need to reject our H naught? Reject H naught when or if, okay, if our sigval is less than our alpha. Okay, so we still have 10 more minutes, okay? Okay, before that, after this, I would like all the Indonesian students to stay, right? So please make sure you stay after class, right? Because I would like to talk to you a few things. Okay, so and then in our case, okay, is it 1 or 2 tail test, people? Anyone? Okay. So how do we decide whether we want to use which tail? Sorry, okay. One, why one?
Because HA is greater than the
Okay, it's one tail, yeah, because it's greater than. So it's going to be on the right or left tail?
be on the right.
Right, okay. So you need to imagine later on, actually your rejection region should be on the right, okay, because it is greater than. Okay, so what is our alpha? Is our alpha given in the question? So what is our alpha?
0.05.
Yes, good. Okay, point 0.05. Okay, and then we are going to continue, all right, in our next lecture. So how to actually enter the data in SPSS, right? So and then we need to find the significant value, and then whether we accept or reject our H naught. Okay, so and then okay, any questions before we stop?
Confirm. Tomorrow. Next Sunday exam is coming out for the chapter is chapter 1 to chapter 7, right?
Yes.
All right. Thank you, Doctor.
Okay. Okay, anything else?
Do we need to use SPSS for the test?
No. For the SPSS, we are going to have a special quiz for that. Okay, anything else? Only the calculation that we have learned, okay, manually. So I'm not going to ask you anything regarding SPSS. So in order for to prepare you all for the final exam, so we have maybe like, 2 quizzes on SPSS before the final exam, just on the SPSS to prepare yourself for the final, right? So anything else? Any other questions? Okay. If not, okay, let me get your attendance. Right. Okay, hold on. The error pula. Ish. Oh, there's something wrong. Sekejap. Tak boleh nak buka untuk the QR code. Okay, let me try again. Okay, meanwhile, any other questions that you want to ask? Ada apa-apa ke nak tanya, nak share or anything? Okay, memang tak boleh buka. Tadi okay. Okay, memang tak boleh for the class attendance today. Alright, so hold on, let me get the attendance by using, okay. Okay. Right. Okay, Esther, are you here?
Yeah, Doctor.
Esther, can you do me a favor? Just do like what you did before for the attendance. Is it okay?
Yeah, sure. The Excel, is it?
Yeah, yeah.
All right.
Can you please help me?
All right, sure.
Thank you. Okay, but meanwhile, I also try to. Okay, for those whose name already appeared in the my screenshot, you can leave the class. Okay, thank you so much. But for the Indonesians, can you please stay? If I miss your name, please let me know.